Hello everyone. In this video, I'll discuss a number system in digital electronics. What is number system? In general, in any number system, there is a ordered set of symbols known as the digits. A collection of these digits makes a number. So that number in a number systems are used to represent some quantities. See, number system is like a ordered set of symbols known as digits. A collection of these digits a collection of these digits a collection of these digits makes a number. So what this number indicate in number system? This number is used to represent some quantities. The number in a number system is used to represent quantities. So number system means any number system we have ordered set of symbols known as a digit. A collection of these digits makes a number. That number in a number system represent some quantities. So each and every number system has radix. We can call as a base, radix or base. So what radix indicates? It denotes number of unique symbols. It denotes number of unique symbols or digits. Available in a given number system. So it denotes number of unique symbols in a given number system. So just we list out what are the number systems are available in a digital electronics. A list first number systems, which type of number system it is, and also radix corresponding to that number system, and also what are the symbols, unique symbols we have in that number system. So since childhood we will use a general number system, decimal number system. If you want to count anything, we will count in decimal number system only. So now decimal. So what is the radix here? 10. What radix indicate here? The number of unique symbol in the number system. If radix is 10, the unique symbols are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So till, what is the range here? We can say 0 to r minus 1. Clear? If the radix is 10, the symbols in this number system is less than that radix only. Now another number system, if we see a binary. So the radix is 2. Here we have two symbols 0, 1. Since in this number system, in decimal number system, we call all these are as a digital digits or symbols. Whereas in the binary number system, we can call these 0 and 1 as a bits. And we have one more number system, octal. The radix is 8. So we have 8 different symbols. We can 0, 1, 2, 3, 4, 5, 6, 7. And one more number system, hexadecimal. We have another number system, hexadecimal. The radix is 16. We have 16 different symbols in the hexadecimal number system. Those are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After that we'll use alphabet A, B, C, D, E, F. So now here A indicates 10. Whereas a B denotes 11, C denotes 12 in decimal. So D 13, E 14 and F 15. So 0 to 15. So in this digital electronic, we are going to study these decimal, binary, octal and hexadecimal number system, and also how to represent a decimal number in different number system, and also convert from one number system to another number system. Now see, if I take one binary number system, now we'll discuss one by one. So binary number system will take binary number system. So what is the radix for this binary number system? So radix is, or base or radix is 2. So we have two different symbols, 0 and 1. So any number in this binary system will represent using only these two symbols, zeros and ones. Now for example, I have a decimal number. Let's assume decimal number 0, 1, 2, 3, 4, 5. So how do I represent these numbers in binary? So we can represent in binary 0, 1, 1 0, 1 1, so 1 0 0, so 1 0 1. This is the binary equivalent for given this decimal numbers. Now see, I have a number, for example, like I'll take 1 0 1. This is my binary number. I want to convert this binary number into a decimal number. All these number system, whatever discussed, binary, hexadecimal, decimal, octal number systems are positional weighted number system. All these are positional weighted number systems. What is meant by positional weighted number system? If let us consider, I'll take one simple number 625 in decimal. This is a number. So each digit in this number has some weights. So some weight associated with the each digit. The weight corresponding to this position is 10 power of 0. The weight corresponding to this 2 is 10 power of 1. For this 6 is 10 power of 2. We can write 6 into 10 power of 2 plus 2 into 10 power of 1 plus 5 into 10 power of 0. So 600 plus 20 plus 5. The decimal equivalent for this is 625. Means each position has some weight. So these all number systems are positional weighted number system. Like the binary also positional weighted number system. If you see here 101. So what is the radix here? 2. What is the radix here? 10. So now the weight corresponding to this 5 is 10 power of 0. Same way in binary number system, the radix is 2. So if you want to write, the weight corresponding to this is 2 power of 0. For this 2 power of 1, 2 power of 2. So if you want to know the decimal equivalent for a given binary number 101, we can write 1 into 2 power of 2 plus 0 into 2 power of 1 plus 1 into 2 power of 0. So we can write 4 plus 0 plus 1. So this is the 5. The decimal equivalent for this 101 is 5. So now I'll take one more example, how to convert this a binary number into octal number. I'll take one more number. So binary to octal. Let us consider 1011 like this. One number is there. I want to convert this number into octal number system. Octal number system. So in octal number system, the radix is 8. So 8 different symbols. What are those symbols? 0 to 7. Now, so here 8, nothing but 2 power of 3. If you want to represent this binary number in octal, we'll consider 3 bits as a one digit in octal number system. Now I'll write this one 1011. So now I consider these 3 digits as a one digit in octal number system. Now these remaining digits as a one number. Add 2 more zeros. Then I'll consider these 3 bits as a one digits. So now what is the equivalent number for this here? So now 0 1 1, this is the 3, this is the 1. So now 1 3 is the equivalent octal number for given 1011. So here we can convert binary to octal. Then I'll give one more number. Now I want to convert this binary number into hexadecimal number. For example, I'll take 10110101 like that. Now if I want to convert this number into hexadecimal, now here in hexadecimal the radix is 16, so we can write 2 power of 4, means the 4 bits group together and represent this 4 bits as a single digit in hexadecimal number. Now I'll take this one and here this 4 bits as a one group. I'll write 10110101. Now I'll group these 4 bits as a one digit and these 4 bits as a one digits. Now 0101. What is the binary equivalent, decimal equivalent for this binary number 010? So 124. This is the 5. Here 1248. This is the 11. So 11 nothing but here we can write B. So in hexadecimal, A nothing but 10, B 11, C 12, D 13, E 14, F 15. Now here this is the 8 2 1, 10 plus 1 11. So that B 5. This is the hexadecimal equivalent for given 10110101. I hope you understand, okay, how to convert a binary number into a decimal and binary number into octal and binary number into hexadecimal. So now this is binary to hexadecimal. This one binary to octal. Binary to decimal. So if any radix in any number system, if you want to convert into decimal radix, then we'll use weighted multiplication. Just we'll take weights and we'll multiply with the corresponding digit, then we'll add, we'll get a decimal number. Then later we'll discuss octal number system. Octal number system. So in octal number system, what is the radix? Radix or base radix is 8. So 8 different symbols, 0, 1, 2, 3, 4, 5, 6, 7. Now here also, if you want to represent that, if I want to count numbers in octal number system, let us consider first a decimal. Okay. In decimal, we can write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 like this. Now corresponding octal numbers, right, in numbers here. So here you can write 0, 1, 2, 3, 4, 5, 6, 7. Then this 8 can be written as 1, 0. And this is the 1, 1. Now I'll tell you how to convert this octal number to decimal. The next number is after 7 is 10 in 10 after 7 in octal number system. Now let us consider. I'll take a simple example. It's 127 have. So now I want to convert this number into a decimal. So now octal to a decimal. So if you want to convert any number system to decimal, then we'll use weighted multiplication. So what is the radix here? Radix is 8. So now 127. The weight associated with this is 8 power of 0. So 8 power of 1, 8 power of 2. So we can write simply here 1 into 8 power of 2 plus 2 into 8 power of 1 plus 7 into 8 power of 0. So here 64, 16 plus 7 will get 87. So corresponding number in decimal is 87. So now this 127 is in octal number system. The corresponding decimal number in decimal number system is 87. So like that I'll convert this octal to binary. Octal to binary. So take same number 127. I'll take 127. It's an octal number. I'll convert into binary. Radix 2. Just now we discussed in octal number system, each digit in octal number system is represented with the 3 bits in binary. So now we have 127. So this 7 can be represented using 3 bits in binary. So now this 7 can be represented as a 111. This 2 can be represented as a 010. This 1 can be represented as a 001. So each digit in octal number represented using 3 bits in a binary number system. So that binary equivalent for this is 001, 010, 111. So this is the binary equivalent for a given 127 in a octal. Now we'll check what is the decimal equivalent for this. Now take this one 0, 0, 1, 0, 1, 0, 1, 1, 1. So now what is the weight associated this? The 2 power of 0, 1, 2 power of 1, 2, 2 power of 3, 4, 8, 16, 32, 64. So just we'll check what is the decimal equivalent for this. 64 plus 16 plus 4 plus 2 plus 1. Now it is 87. The decimal equivalent for this binary number is 87. Now we'll take same number 127. The decimal is 87. Here also we will take octal number. So the decimal equivalent binary number is this one. The decimal is 87 we'll get. Now we'll discuss how to convert this octal number to hexadecimal. Octal to hexadecimal. I will take same number 127. So now I will convert into hexadecimal number 16. But while converting this octal number into hexadecimal, we need to follow the 2 steps. First, we need to convert this octal number into binary. After binary to hexadecimal. Now we need to follow 2 steps. Here, step 1, first octal number to binary. In step 2, we'll convert binary to hexadecimal. We'll see here 127. Just now we find the binary equivalent for this 127. In step 1 we'll write so 127. So the binary equivalent is already we got here. So 0, 0, 1, 0, 1, 0, 1, 1, 1. This is the binary equivalent for this 127. So this is step 1. Step 1. In step 2, we'll convert this binary to hexadecimal. So while converting binary to hexadecimal, we'll group these 4 bits as a 1 digit in hexadecimal. Or remaining these 4 as a 1 digits. So remaining these 4 as a 1 digit. For example, here only 1 bit, we can add 3 more bits. If it is 0, no problem. If for example, if I have 1, then it has some values, then you can append zeros to this left side. So now what is the 0, 1, 1, 1 here? 4, 2, 6, 7. So 0, 1, 0. So 5, this one is 0. Now corresponding hexadecimal is 057. So now we'll discuss hexadecimal. How to convert hexadecimal number to binary, octal as well as a decimal. Hexadecimal number system. So in hexadecimal, radix is 16. So we have 16 unique symbols. Those are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E and F. So now A is that equivalent in decimal is 10, 11, 12, 13, E 14 and F 15. Now I'll convert one hexadecimal number to binary. So now if I consider one hexadecimal number system, let us consider 3F. Now this is in hexadecimal. So hexadecimal to decimal. Now I have 3F6. Now I want to know the decimal equivalents. So if you convert any number system from any radix to decimal, then just we'll use weighted multiplication. So that weight associated this F is 16 power of 0. This is 16 power of 1. Now we can write 3 into 16 power of 1 plus F into 16 power of 0. Now here 3, 48, F nothing but 15. You get 15. Here 63. So the decimal equivalent for this 3F in hexadecimal is 63. We'll take same number and we'll try to convert into binary. So hexadecimal to binary. I'll take this same number 3F16. I want to convert into binary. So if you want to represent this hexadecimal number in binary, each digit in hexadecimal number represented using 4 bits. I'll write 3F. So now this F I can represent it in binary, all ones, 4 bits. This I say 0, 0, 1, 1. So now this is a 2 plus 1, 3. These are like a 8 plus 4 plus 2 plus 1. This is a 15. So the corresponding number is 0, 0, 1, 1, 1, 1 like this. This is the binary equivalent for this hexadecimal. I'll convert this hexadecimal to octal number system. Now hexadecimal to octal. Octal. We'll take a same example. Here I'll take 3F. Now I want to convert this into octal number. Same way we did in octal number system. If you want to convert hexadecimal to octal, we have to follow 2 steps. Here step 1 is convert this hexadecimal to first one binary, then binary to octal. This is step 2. Now first we'll convert this 3F into binary. Just now we did here. So that 3F in hexadecimal, that equivalent binary number is 0, 0, 1, 1, 1, 1, 1, 1. So now here we'll take, this is the binary number. So now we'll convert this binary number into octal number. So if you want to represent this binary number into octal, we'll group these 3 bits, make it as a 1 digit in octal number system. So now we can write this is a 7 and 4 ones. I think 0, 1, 1, 4 ones. So now it is as a 7 and zeros. Now we'll get 0, 7, 7. This is the octal equivalent for given 3F in hexadecimal. I hope you understand how to convert binary and octal hexadecimal to another number system. Now we will discuss how to represent a decimal number in binary, octal as well as the hexadecimal. So convert a decimal number to any radix number system. Any radix number system. So we'll follow two procedures. One is for integer. For integer, we'll follow successive division. For fractional parts, we'll follow successive multiplication. Successive multiplication. Now I'll take one number, then I'll try to convert into binary. Now here I'll take one number, example I'll take 41 in a decimal. Now I need a corresponding binary number. So it is an integer, so we need to follow this procedure, successive division. I'll take 41. So what is the radix? The target radix is 2. Now I'll use successive division to 20. So what is the remainder? Is the remainder here? Remainder is 1. Now 2 times 20, remainder is 0. 2 5s are 10. Okay, remainder is 0. So now here 2 2s are 4, remainder is 1. 2 1s are 2, remainder is 0. We can write here 2 0 0, remainder is 1. So now this is the binary equivalent for the given 41. But we'll write like bottom to top. Now this is a 41 decimal. The binary equivalent is to write from bottom to top. 1 0 1 0 0, this one. This is a binary equivalent for given decimal number. We'll check whether it is correct or not. So now what is the weight associated with this? 2 power of 0, 2 power of 1, 2 power of 2, 2 power of 3, 2 power of 4, 2 power of 5. Think about 32, here 8, here 2, here 1. Clear? So 32 8. So 32 plus 8 plus 2 plus is a 41 in a decimal. So now if you want to convert a decimal number to a binary, then we'll use successive division with radix 2, and we'll take this remainder from bottom to top, that represent the binary equivalent for this 41. So now for example, it has some integer part. Let us consider, now I want to convert this number. Now let us consider I have a number 0.6875. This is my decimal number. I need to convert into binary. Now here for fractional part we'll use successive multiplication. So now here I'll take a 0.6785, then I'll do here 0.6875. We have, after multiplying with this targeted radix 2, we get some number, and also it contains both fraction as well as the integer. So if I multiply with this 2, then I'll get a number. Okay, that number is 1.3750. Now has a fraction 0.3750 and integer 1. Now I'll take this fraction, then I'll perform, right? So now 0.3750 into 2, I'll get a number. So that is 0.7500. I'll get this. So for this number, the fraction is 0.7500. The integer is 0. Now I'll take this fraction 0.7500 multiply with 2, then I'll get a number like 1.500. Now this here the fractional part is 0.500, whereas this integer is 1. Now I'll take this fractional part, new fractional part, 0.500 into 2, then I'll get a number like here 1.000. So fraction is 000 and that integer part is 1. We need to continue this procedure until the fraction is 0 or to get some required number for a given precision, for accuracy. Clear? So now what is the binary equivalent for this? Now top to bottom will take. So now this is a 1, 0, 1, 1. This is the binary equivalent for given 0.6875 in a decimal. Now if I ask for example, if I ask simply 41.6875, what is the binary equivalent for this? Just in the previous slide, okay, here. So for 41 we have 101,001. So now we can write 101,001, and as it is we need to mention this decimal point. Now what is the binary equivalent for this? Just now here 10,10,11. So this is the binary equivalent for this 41.6875. So we'll use successive division as well as the successive multiplication to convert decimal number to any radix. So now until we'll get fraction as a 0 or some digits to specify the specified accuracy. So now we have to perform this operation until the number of digits has sufficient accuracy. Clear? So sometimes we may go infinite also. We won't get a fraction value as a 0. So up to few digits we need to stop and need to verify what is the accuracy. We need to decide. Okay. Then now I'll convert decimal number to hexadecimal. Right. I'll take one example here. I'll take 2598,675. Now this is my decimal number. Now convert to corresponding hexadecimal. So same successive division, successive multiplication will follow to convert this decimal number into this hexadecimal. For this integer part will follow successive division, this fractional part successive multiplication. I will take 2598. So the radix, the target radix is 16. We are divided with the 16. So 16 162. So here remainder, we will write remainder. So remainder is 6 here. So 16 10 160, remainder is 2. So now we will take here 16 0, 16 0 0. Now the remainder is 10. So what is the 10? 10 nothing but in hexadecimal we can write this as a. Now the hexa number equivalent for the given number is a to a 6. For integer part this is the hexadecimal equivalent number. Now we will take this 0.675. Now we want to convert this number into hexadecimal. So here we will use successive multiplication. So we multiply this fraction with a radix. Now we will get a number. Then we will take as a integer and the fraction, new fraction. Then again the new fraction is multiplied with this radix 16. Now take a 0.675 multiply with the 16. We will get some number. So now here we will get a fraction part as well as integer. Now if I multiply here, then there's 10.8. The fraction is 0.8. The integer is 10. Then this fraction I'll take 0.8 multiply with the 16. I'll get and 12.8. Now the fraction is 0.8, the integer is 12. Then I'll take this 0.8 and 16, and once again I'm getting 12.8, the fraction is 8, 0.8 and integer is 2. I'll take this 0.6 into 16, that number is 12.8, the fraction is 0.8 and integer is 12. So this process is continue infinite times. So we have to stop until we get fraction is 0, or that the number of bits are sufficient to represent the given accuracy. Now we can represent this like this 0.675 in hexadecimal as a, this 10 means A. So this is a C, C and C. We can write 0. A, C, C, C like that. So now if I want to write 22,509.675, then hexadecimal equivalent number is here. We'll take per integer part we got A26, for fractional part we got A, C, C, like so 60. This is the approximate of this decimal number. I hope you understand how to convert a decimal number into hexadecimal by using a successive division and successive multiplication. That number has a both integer part as well as the fraction part. So now we'll discuss how to convert a decimal number to octal number. I'll take one more example here. So now I'll take a 153. This is a decimal number. I want to convert into octal number. So now we'll use integer part, successive division. Take 153 and division with this radix 8. 8 90. The remainder is 1 here. Remainder is 1. So 8 to the 16. So remainder is 3. 8 0 0 0 0. No 2. Now we'll take top to bottom. The corresponding number is 2 3 1. Clear? So now we'll get octal equivalent for this 153. So same way have an fractional part. Let us consider 0 513. My number 0 513. I want to convert a decimal. This is hexadecimal. Now I convert into a decimal. Convert into octal. So now we'll perform successive multiplication. Take 0.513 into 8. We'll get some number. So 4.104. So what is the fraction part? What is the integer part? We have to write individually and we'll take new fraction. Now here 0.104, integer is 4. Now I'll take this new fraction 0.104 multiply with the 8 and I'll get 0.832. Now new fraction is 0.832. The integer is 0. Now I'll take this new fraction 0.832 multiply with the 8. I'll get 6.656. The new fraction is 0.656. Then integer is 6. I'll take this 0.656 as a new fraction. Then multiply with the 8. Then I'll get 5.248. So new fraction is 0.248. The integer is of 5. I'll take this new fraction 0.248 multiply with the 8. Then I'll get 1.984. The new fraction is 0.984. The integer is 1. Now we'll get. So I think we required, so 3 bits are sufficient to represent to given accuracy, for given accuracy. So we can write like this. It continue. So what is the equivalent number in the octal for this? So we can write here 40651 like It's a octal equivalent for given this number. In case of fraction, we'll give successive multiplication. I hope you understand how to convert one number system to another number system. For example, if you see in binary, like in binary number system, I have a number like this. For example, I have a number 1110. I have a number. If I ask corresponding decimal number, so what is the weight associated this digit? 2 power of 0, this is 2 power of 1. So the weight associated with this is 2 power of minus 1, this is 2 power of minus 2. I'll get 1 into 2 power of 1 plus 1 into 2 power of 0 plus 1 into 2 power of minus 1 plus 0 into 2 power of minus 2. Now 2 plus 1, and this is the 0.5 and plus 0. So this is the 3.5. It's a decimal equivalent for a given binary. So even though it has integer as well as a fraction parts, so same way it is applicable for octal and hexadecimal also. There will take after decimal point 8 power of minus 1, 8 power of minus 2, like that in octal. Whereas in the hexadecimal, we will take 16 power of minus 1, 16 power of minus 2, like this. So in this class, I discussed what is meant by number system, what are the different type of number system, how to convert one number system to another number system. So number system, in general, in any number system, there is a ordered set of some symbols known as a digits. So by grouping these digits, make it number, that number represents some quantities. So we have various methods to represent the numbers in a digital system like hexadecimal, binary and octal. I hope you understand number system and how to convert one number system to another number system. Thank you.